We're going to explore now what is known as the method of elimination in solving a system of linear equations. And we're going to start with something very simple. I have two examples here, and we're going to look at them in conjunction each step of the way. And what this first part asks me to do is to just add the systems together. Now what that means is, just like in a regular addition of numbers, what you do is you're going to add all the x's, all the y's, and all the coefficients. So here, it's supposed to be nothing. If I add the x's together, I get 2x. And if I add y and negative y, I get 0y, which I can just write as 0 itself, because 0 times y is 0, 0 times anything is 0. And then for the coefficient, I have 18. This in turn can be rewritten as 2x equals 18, because 2x plus 0 gives me just 2x again. Now the same thing is over here. I'm going to add these together. This time notice that when I add the 2x and the negative 2x, it cancels to give me 0x. On the other hand, the negative y and the positive 3y, when I add them together, I end up with positive 2y. Again, we add the coefficients, so negative 1 plus 3 gives me 2. And finally, 10 plus negative 6 gives me 4. So what I end up with here, again, I can ignore the 0x, or you can think of it as just 0. I end up with 2y equals 4. So that's what it means to add equations together. Just like you're adding numbers, you stack them on top of each other and add the like terms together. So what did you notice about one of the variables? When you added and subtracted, you noticed that one of the variables disappeared or was eliminated, which is the whole purpose of this lesson. Notice that over here the y was eliminated, and over here the x was eliminated. So let's move on. It asks that we solve for the variable that is remaining and find out what it is. So in the first case, we have 2x equals 18. So I'm just going to rewrite that over here. We have 2x equals 18. And if I solve for the x value, I get x equals 9. Again, here I divide by 2, here I divide by 2. In the second one, we had 2y equals 4. So I'm just going to take that, actually, copy it, paste it here. Just put it over to the side. Actually, maybe I'll put it back down here. And delete that underline. So to solve for y, we divide both sides by 2, divide by 2, and I end up with y equals 2. So the answers we got in 1 and 2 we used to solve for the remaining variable. So in the first one, we had x equals 9. If I want to solve for y, I plug that value for x into any one of the original two equations. So in this case, let me pick, say, the first one. So I'm going to take that one. I'm going to replace x with 9 plus y equals 14. Again, this was my x value, but I replaced it with 9. So I'm now going to solve for y, and I end up with y equaling positive 5, because 14 minus 9, the 9 comes over to the other side, and it is subtracted, leaves us with 5. Similarly, over here, we have y equals 2, so I have a 2 value over here, and I want to solve for x, so I can pick any of the two equations that were initially given to me. Rule of thumb, try to pick the one that has less work, in the sense that it has smaller number coefficients. I think this would probably be a wiser choice, because the y doesn't have anything attached to it other than negative 1, which is easy to work with. So I'm going to replace the y with 2 equals 10, and then solve for x. So this negative 2 here comes over the other side. Tidy this up, and I get 10 minus 2 to equal 8. Divide both sides by 2. Cancel, cancel, and I'm left with x equals 4. So there we have it. The solution to the first one, our x value is 9, the y value is 5. The solution to the second one, the x value is 4, and the y value is 2. And all of this here is known as solving a system of linear equations using the process of elimination.